بسم الله الرحمن الرحيم.
Assalamu alaikum and a very good morning to all of you students. Here is the time to learn the physics of class 9th. Previously, we have started chapter number 1 and we had completed that chapter with the homework to learn the whole chapter from notes or from your book. Hope you must have learned that chapter because it was the totally theory based chapter. Now, today onwards, we have to start chapter number 2. Chapter number 2 is the measurement. First of all, let me give you the introduction of the measurement. What is basically the measurement? There will be few confusing terminologies in this chapter, but you have to categorize them all clearly. What is measurement now first? Measurement is basically our everyday practice. Like if we have to measure anything, or suppose we have to go onto the shop and we have to purchase the sugar, flour, we must have to tell the shopkeeper that give us 1 kilogram sugar, 2 kilogram sugar, 3 kilogram sugar. Means the sugar which we are buying, that what is the measurement of that sugar? The measurement of that sugar, we are buying that sugar in the mass or in the weight we are buying that. Means 1 kilogram is the weight. 2 kilogram is the weight. Weight is basically the measurement. Similarly, if we have to purchase the cloth, fine, we purchase the cloth in the meter. Fine, means we purchase like 2 meter cloth, 3 meter cloth, 1 meter fabric. So this 1 meter is basically the length, and now length is basically the measurement. Similarly, if we have to purchase any liquid substance, like we have to purchase petrol, we have to purchase milk, or we have to purchase water, we measure that into the liter. And then liter, the 1 liter, 2 liter, 3 liter onwards. That is basically the volume of the milk, water, or the oil. So that volume is basically the measurement. So what is the measurement? Measurement is basically our everyday practice of buying anything or to measure anything. Like length is the measurement, volume is the measurement, we have mass is the measurement, temperature is the measurement, we have density is the measurement, speed is the measurement. These all the words which I have given you the example, these all are the measurement first. To measure these quantities, we use particular units. That is the onwards topic. So what is measurement? We can define the we can understand the measurement as that it's an everyday practice. But how we will define the measurement? We will define the measurement comparison of unknown physical quantity. It will be our next topic. Unknown physical quantities with their standard units. Now, physical quantities is our next topic, and standard units. Standard units means if we have to purchase, suppose the sugar, flour, we are purchasing that into the mass. What is the unit for representing the mass? That is kilogram. This kilogram is basically the standard unit of mass. Standard unit means which is used in the whole world basically. Similarly, if we have to purchase a cloth, we have to purchase that cloth into the length. How do we measure the length? We measure the length either into the meter or into the kilometer. Depends on the length. If it will be very lengthy, we will if we are measuring the road, we will measure that into the kilometer because it's very lengthy. While if we are measuring cloth, we measure the cloth into the meter. That meter and kilometer are basically the standard units. And what are the measurement? Length, volume, mass, temperature. These are the measurement. In which they will be measured? That is known as the standard units. Here we have the measurement of two types. That is, first of all, measurement can be pronounced as the physical units as well. Physical units, if you will go to the particular meaning of the physical quantities of any substance. Physical quantities of any substance means measuring the physical property. Suppose we have a scale or we have a rod. Fine. You can see the physical property of this scale. It this one area or this one part is showing you the length, and this one part is showing you the breadth. This length and breadth is basically the physical property of this ruler. Now the physical property, to measure the physical property, they will become the physical quantities or the measurement. Suppose we have a car or any vehicle. This car must be having some physical properties, and that property will be the physical quantities. Physical property means it will be having somewhat length, it will be having breadth, or it will be having somewhat mass or weight. That mass, length, breadth is basically the physical properties of this car. And to measure these physical properties, that is known as the measurement, and it is also known as the physical quantity. So we can say this mass, length and breadth are the physical quantities. Hope you have understood what are the physical quantities or the measurement. Both resemble with each other. Fine. Now we have the two types of physical quantities. First we have the fundamental quantities. Fundamental quantities can also be called as the base quantities, or if you will understand the meaning of the fundamental quantities or the base quantity, it means that they are independent. They are the independent quantities. Independent means they do not rely on other. Like length, fundamental quantities examples are length, temperature, we have time, current. These all are the fundamental quantities. I have written here only 4 examples. You can see the table 2.1 on page number 16 to see all fundamental quantities. I have mentioned here only 4. There is a table 2.1. Just have a look in your book on page number 16. Here are the fundamental quantities table. Now length is the fundamental or the base quantity. It doesn't depend on any other quantity. I will tell you how it is the dependent or how the independent. Now these are the independent quantities. They do not rely other quantity. Length, we can mention the length by smaller l. We may similarly temperature, we mention the temperature by capital T. Time, we mention the time or we symbol the time with smaller t. Current, we symbol the current with capital I. These are the symbols of these fundamental quantities or base quantities, or they are the independent quantities. They do not rely on other quantities. Now, the unit to measure these quantities like length symboled as L. How do we measure the length? That is the meter. We can measure the length in meter, kilometer, etc. Similarly, temperature, we measure the temperature in Kelvin or in centigrade. Similarly, we measure the time in seconds, and if we will be having the larger unit, that will be the minute, then we will be having the hours. I will teach you the units as well later on. But these are the basically standard units which I am telling you here. Current, its unit is the ampere. Fine. So, fundamental quantities are measured in particular units. Now have a difference between the quantities and units. These are the quantities or measurement. Length, temperature, time, current are the quantities or measurement. How do they measure? That is known as the units. So meter, Kelvin, seconds and ampere are the units. So we can define another term, that is fundamental units. What are the fundamental units? Our topic is continue from here. Fundamental quantities. Here are the example of fundamental quantities and here is the fundamental units. What are the fundamental units? Units to express units used to express fundamental quantities units used to express fundamental quantities are known as the fundamental units. Like meter is the fundamental unit, Kelvin is the fundamental unit, second is the fundamental unit, ampere is the fundamental unit of particular quantities which we have written here. So here is the difference, or here is the bit introduction of the fundamental quantities and fundamental units. I hope it will be clear. I am repeating that now. What are the fundamental quantities which are independent, which, or you can say these are the physical property of any substance, of any material which we can measure. Means I have given you the example of the car. That car will be having particular length. Here is the length, it's the physical property. Similarly, that car, wherever, whatever is the environment in which the car is standing, there will be somewhat temperature. Temperature can be higher or temperature can be lower. At that time, what will be the temperature? It will be the physical quantity of that car. Similarly, we will be having the time. Means at what will be its speed? That will be the time. It will be included in the speed to calculate the speed of that car. Fine. So these are the fundamental quantities are basically the physical property of any material, of any object, of or any substance. To measure these fundamental quantities, we have some particular units which are known as the fundamental units. The table for fundamental quantities is on page number 16 and the table is 2.1. Now we have the next quantities. These are the derived quantities. I am not removing the base quantities so that you can come to know the difference. Derived quantities are basically the quantities which are quantities derived from fundamental quantities. Derived quantities basically depend onto the fundamental quantities. That is why we can say derived quantities are dependent quantities. Fundamental are independent, they do not depend on other quantities, while derived quantities are dependent on fundamental quantities because they derive from the base quantities. The example of the fundamental quantity is volume. Suppose here is a block. A block having three dimensions: length, breadth and height. Here is a block. This block having this dimension is showing you the length. It is showing you the breadth of the block, while this part is showing you the height of the block. The dimensions are changed. The height, length and breadth are the dimensions basically of this box. When we have to calculate the volume, we must know about the what is the height of this box, what's the length of this box, what's the breadth of this box. These all will be multiplied. So volume basically is equals to the multiple of length, breadth and height. Then we'll be having the volume. All of these length, breadth and height will be measured into the meter, kilometer or centimeter, depends on the volume. If it will be very larger, so it can measure in the meter. If it will be very smaller, it can be measured into the centimeter as well, depends on the box. So these all will be measured into the, suppose they are measuring into the meter. At that time the unit will be basically of the volume will be, it will be meter. Suppose length is 1 meter, breadth is 1 meter and height is also 1 meter. When they all will be multiplied, the volume will be 1 meter cubed. Means this one unit which is the meter cube, it is the multiple of length, breadth and height. Means volume is basically composed of the 3 measurements. That 3 measurements are length, breadth and height. Because it's a composition of more than one property, more than one quantity. That is why such kind of quantities which having more than one quantity, these are known as the derived quantities. Similarly, take another example. There is a velocity or the speed. Another example of derived quantity is velocity or the speed, or in easier word if you will understand, speed or velocity. When we measure the velocity, to measure the velocity the unit will be meter per second. Meter per second means meter upon second. Meter is the unit of length while second is the unit of time. Means right now velocity is basically, if I will go to the formula of velocity is length upon time or the distance covered by any vehicle. Length or distance covered by any vehicle in particular time, it will be known as the velocity. This velocity is basically composed of two fundamental quantities. In fundamental quantity, this length is a separate and time is a separate quantity. This time, because velocity is composed of more than two fundamental quantities, that is why it is known as the derived quantities. So we can define the derived quantities as the quantities derived from the fundamental quantities are known as the derived quantities. Now there is, hope you have understood. We will be having more examples to understand derived quantities when we'll study the chapter number 3. Fine. Okay, there is a table of derived quantities. It's on page number 17. You can see the table is on page number 17 of derived quantities. The table number is not mentioned in your book, that's why I'm not telling you. It's on page number 17. There are more than 7 derived there are 7 quantities, derived quantities you can see. Now what are the next is next we have the derived units. What are the derived units now? Derived units are units used to express derived quantities. Units used to express the derived quantities are known as the derived units. I am again telling you, have a difference between the quantities and units, because it makes you confused whenever you are solving the numericals. What is the quantity and what is the unit? You will be confused. I given you the example of volume. Volume is the derived quantity. Meter cube is the derived unit to measure the volume. Similarly, I have given you the example of velocity. Velocity is the derived quantity. To how do we express this velocity? It is expressed in meter per second. This meter per second is the derived unit, while velocity is the derived quantity. Keep difference in between the quantity and units. Again and again I am telling you because it makes you confused. Now beta, we have the next topic, that are the standard quantities. Our topics of today is measurement, physical quantity. There are two types of physical quantities, fundamental quantities and derived quantities. Related to fundamental quantities, we have the fundamental units definition. Related to derived quantities, we have the topic derived units, and we have the particular table of derived quantities and as well as of the fundamental quantities. Now we have the next topic. There is the topic is systems of units. Now we have the next topic, that is systems of unit. Means how many systems has been introduced to show the units of particular quantities. We have three systems of unit. First one system is CGS, CGS system. CGS basically stands for centimeter, gram and second. Centimeter, gram and second. Now according to CGS system, the centimeter is basically the basic unit of length. Gram is basic unit of mass and second is basic unit of time. Means these systems of units are telling that if we have particular quantities, what will be their standard units to measure those quantities. Time will be measured into the second according to this system. Length will be measured into the centimeter according to this system, and gram will be used to measure the mass. While the next system we have SI system, which is completely we say that system international or the international systems of unit. This one system, SI system, is basically used worldwide to show the units of particular quantities. There are 7 quantities according to SI system, and those quantities are length, length, temperature, current, mass, luminous intensity, there are 7 units. 5. Amount of substance, and time. According to System International, there are 7 quantities, and what are the units to measure these quantities? For length, we have the unit meter. These are the units which is used internationally, means worldwide these units are used to measure the length. Temperature is measured into the Kelvin. I am just mentioning here, length will be measured into the meter. Temperature will be measured into the Kelvin. Current will be measured into the ampere. Mass will be measured into the gram. Luminous intensity, it will be measured into the candela. This whole table is also present in your book on page number 16 or 17. Amount of substance is measured into the mole and time is measured into the seconds. Means these are the units which is used to measure these seven quantities. Now here will be the confusion with the terminology. Luminous intensity, all the terminologies will be clear to you. Luminous intensity, what is? Luminous means luminous objects you must have studied, that is the objects which produces their own light, like sun is a luminous object, sun is a luminous object. So what is the intensity of its light? You can say how much you can say either its light is very intense or its light is very dim. That intensity is measured, that is known as basically the luminous intensity, and this luminous intensity is measured into the candela. Similarly, we have the torch light. Sorry, torch will be not the, it's not the independent, it's not the dependent. Well, take the example of right now only of the sun. Luminous intensity is basically that how much the intensity of light, either the higher or the lower, it is measured into the candela. It's the second systems of unit, that is System International SI system. First one is CGS. According to CGS system, we have three fundamental quantities: length, mass and time, and the units are centimeter, gram and second respectively. Similarly, in System International, we have seven quantities, and those seven quantities are length, temperature, current, mass, luminous intensity, amount of substance and time. You can see this table on page number 16 or 17 in chapter number 2. Now the last one system is British engineering system. Now, according to British engineering system, there are three fundamental quantities. There is length, force and time. These are the three fundamental quantities according to British engineering system. And according to British engineering system, length is measured into the foot. We measure somehow the length in foot, 1 foot, 2 foot. 1 foot is basically is equals to 12 inches. Fine. So according to British engineering system, the unit to express the length is foot. To measure the force, there is a unit pound, and to measure the time, the unit is seconds. Now you will be confused that why these systems are here and what do you mean by the units? Means internationally somehow we can use to measure many measurements. Different systems were introduced in their time that according to them length will be measured into the foot, means it will be a standard unit. If we are purchasing any cloth or if we are covering any distance, that distance will be measured into the foot at that time. But later on it was changed. It is not considered as the international unit to measure the foot. It is the unit, but it's not the international unit to measure the length. Similarly, according to British engineering system, force having the unit pound, while now the force unit is Newton. At that time, according to British engineering system, to measure the force, we use the unit that is pound. Similarly, to measure the time, we use the second. Still, the second is the unit to measure the time. Similarly, we have SI system or the System International, which is still now used in the whole world to measure the particular quantities. And the last one is the CGS system, which is the abbreviated form of centimeter, gram and second. And according to this system, length, mass and time are the fundamental quantities of these units respectively. Now, here we have to start a next topic, that is standard of length, standard of time and standard of mass. I'm just teaching the topic. I'm not in the sequence. The topics are not in the sequence, but the topics which I am teaching here, it will be as your homework to learn. After the systems of unit, we have the topic that is standard of length. Means what is the standard unit to measure the length? That is meter. It's the standard unit to measure the length. Similarly, we have standard of time. These all having particular definition which I will teach you in the next class because it's the lengthy topic, and its unit is second, while the last topic is standard of mass, that is kilogram. To mention this topic here, while I am not teaching, you have to read these topics yourself right now, but I will teach you later on. Now, what the topic I have taught you? Quantities, physical quantities, fundamental and derived quantities, fundamental units and derived units, and then I have taught you the systems of units. These all are the topics which are the top topics today. It's your homework for learning. From where you will learn, you can learn all these topics from your book. Page number 13, there is the topic physical quantities. All the topics which I have taught you, all topics definition are present in that topic physical quantities, which is on page number 13 and 14. Our next topic is standard of length, standard of time and standard of mass, which I am not teaching you here, but you will just read that topic, so I can easily teach you this topic in the next class. Your homework is to learn today's topic, and the next one is you have to do the exercise, that is of MCQs, blanks and true false. That is exercise number 2.2, 2.3 and 2.4. You have to do that exercise in your book. The next one work is to do the problems 2.2 till 2.4. You just write those numericals in your copy and leave that page, because we will solve that numericals ourselves in the class, and then you will write it down in your copies on the same time when I will teach you, when we will solve on the board, because you cannot solve that yourself. Just you will write those problems in your copies. I am winding up my class with a hope that you will learn all the taught topics of today, and you will copy the work which is mentioned in your homework schedule. In homework there are numericals, but you will not solve those numericals, you will just write down only numericals. Okay. Thank you so very much. Must read this topic so that you can easily understand.